MC for the next 2 days for this room. So I'd like to welcome you all to our first speaker, Roy Ashok from Vuforia. Well, from Qualcomm, who will be presenting on Vuforia. So whenever you're ready.
Thanks, Damon. Good morning. How many of you have heard of Vuforia? Non-Qualcommers. Oh, okay. Excellent. Okay. So, well, Vuforia is actually the new name and branding which was unveiled at CES for what was formerly known as the Qualcomm Augmented Reality Platform. Some developers used to call it QCAR or QCAR. So welcome to this session. It's an introductory session on Vuforia. My name is Roy Ashok. I'm the Senior Manager of Business Development at Qualcomm Research. I'm also the Product Manager for Vuforia. So what we're going to do today is we'll go over the platform, look at it from a very high level, look at some of the key features and capabilities of the platform, and then we'll see how it's doing in the marketplace, the acceptance and the types of apps, and also look at the traction, basically. And then finally, for the fun stuff, I'll open up the Unity game engine, and I'll show you how our tools are used with that game engine to build this very simple app. So it'll give you a flavor for how easy it is to use our tools. Now, we've had this SDK out there for about, for a little less than 2 years in either beta or commercial form. And I think apps were, since last April, Android apps, and then since last August, iOS applications have been appearing in the Google Play and the Apple App Store. So what I want to do is give you a little flavor of the types of the more recent applications that have been built with this, with our SDK. So let me play a quick video here. So lots of apps in various categories. So let's actually talk about what those categories are. I think fundamentally Vuforia enables 3 application categories. The first is gaming and play, interactive media and marketing apps, and then instructional applications. So gaming, so this is all about, today you play a game on your phone, right? You hold it, you're pretty much holding it static, maybe you tilt it, there are some simple motions associated with that. But by and large, the experience is static. You're either standing and playing it or you're sitting in one place. But with augmented reality, because you can have that experience in the real world on a game board or a target, you can actually build very interesting interactions where you're moving the phone back and forth or you're walking around the target. So it's very, adds a completely new dimension to gaming. And I think there are lots of applications here which we're just barely scratching the surface. And then play, you have toys today, actual physical toys. You play with them in a particular way. And AR adds a nice complementary experience to that just brings these toys to life and brings new play patterns to the whole experience. The second category is interactive media. And this is where we've seen a lot of traction in the last year. And I think the reason is because augmented reality has this unique ability to connect with users at 3 points in the sales lifecycle. The point of advertising, where you're taking a print ad or an ad in a newspaper, magazine, or a retail end cap, and you can really engage the user there. or at the point of sale, where someone is walking through an aisle in a retail store or a grocery store or supermarket, and then you can engage with products or product packaging in a completely different way that was not possible before. And then finally, at the point of use, where you buy this product, you take it home, you use it for what it's intended for, but then you put it away in a closet or you don't use it that often, and then augmented reality is a way of drawing that product out and making you use it again and again. And I'll give you an example of that last one. There was a campaign in the UK for Weetabix, which is a cereal maker, and apparently Weetabix is very nutritious but doesn't taste all that great. So mom would buy it, and then kids would take it and put it in the closet and never take it out. So Weetabix designed a campaign that forced children to bring that box out and have an AR experience on it. And what they did was they built this beautiful game that kind of looked like, look and felt like Little Big Planet on the PS3, where you have these creatures. And there's this world that was completely destroyed by some evil creatures, and it's your job as Vita Kid to go and replenish this world. So that's a proper game that you just play on your phone, right? But the way to replenish that world requires energy, and the only way you can get it is you get that box out of the closet, and you have an AR experience where you go and jump into a cereal bowl of Weetabix and milk and get that. So that whole idea of getting that product out and putting it on the table and having that experience solves a very specific problem there. And then the last category of applications is instructional apps. So this goes back to the roots of AR, and aircraft maintenance, where you had this technician go into a plane and there's all kinds of wiring diagrams out there, and he had this manual where he'd have to flip through the manual, look up the wiring. It was too much. So they gave him a heads-up display and overlaid the wiring diagram on that harness so he could actually look up and see, and that was a much better experience and easier to maintain these aircrafts. So with the technology we have today, we've brought the same thing to a phone. So now your phone becomes a see-through user manual for appliances and devices in your home or office. So you can point at, imagine, I'm personally challenged by washing machines, for example. The only thing I know out there is start and stop. I don't know what those advanced programs are. So imagine if I pointed my phone straight at the washing machine, and right there I got step-by-step instructions or explanation on specific programs, or if I had a problem with the machine, I know how to troubleshoot it. So there's all kinds of applications, sort of common, what I call sort of common consumer applications for devices that are around you, that's possible with instructional apps. And all these categories are enabled by Vuforia today. So let's now switch gears and talk a little bit about the Vuforia platform itself. There are three main components to this. There are device-side SDKs for both Android and iOS, and an extension for Unity that you can just plug into Unity and build cross-platform apps. We also have online tools that help you manage all the images that you want recognized and different types of that are sort of exemplary of real-world objects. And then we have a strong community forum that's been growing. We have thousands of posts and hundreds of threads all the time. There's like throughout the day, anytime you go there, there are like at least 100 or 200 users out there actively posting. So it's a really strong community, and it's growing. I wanted to introduce to you the key features of the SDK, and I think the best way to do this is actually talk about some of the sample apps in the, that ship with the SDK. Each sample app today talks about a very specific feature, computer vision feature that the SDK is capable of doing. So for example, the ability to recognize natural feature images, not 2D barcodes, but any picture or image that you take of the real world. A special kind of marker that's not as bad as a 2D barcode, but has a little black border around it that allows the marker to go really small. And then some real-world interactions called virtual buttons. So let me play a short video that actually shows you this so you get a quick overview of the platform's capabilities. If I can get my mouse. The Qualcomm augmented reality platform is a computer vision-based solution that offers a software development kit, or SDK, to developers to build compelling and exciting augmented reality applications. The SDK is freely available for download, and we've included a number of sample apps to help kickstart development. The image target sample app is actually the entry point for all developers. It's really the first application that developers should look at to understand how to use the SDK and how to render a simple 3D graphic on top of a real-world image. For example, stones, but it could really be any image that you take which has sufficient detail and that can be tracked. The frame markers allow you to track any image within a little black boundary around it. The frame markers can actually be much smaller than image targets, and you can have many frame markers tracked simultaneously. The SDK provides about 512 frame markers, and you can pick any of them to work with your application. In the frame markers sample app, what you'll see is we've taken the first 4 frame markers, which have actually predefined IDs 0, 1, 2, and 3, and then we've rendered some simple 3D alphabets on them, in this case ARE, which is our platform. The advantage that you have with frame markers is that within the black boundary, you can have pretty much any image you want. Multi-image targets actually introduces a very interesting new concept to the SDK, the ability to detect and track simple 3D objects such as boxes. If you notice our sample app, we actually have a little graphic which is a bowl revolving around the 3D box. And what that shows is really you're detecting and tracking in 3D, and as you turn the box around, the bowl is actually occluded. That's a very interesting feature of our SDK. The virtual buttons are a new form of interaction. They're actually interactions with the real world. We allow the developer to mark certain regions of interest on an actual image target. In our sample app, we have 4 virtual buttons on the image target itself. And when you press each of those buttons, it changes the color of the teapot that's rendered on the printed target. So it's a very different form of interaction that's not available in non-AR applications. Dominoes is actually a simple game that shows how to integrate various features of the SDK with different components in the Android operating system. Some of these components are only available in Java, and some of them are available in the native side of Android. So we wanted to build one complete app that actually shows the developer how to use these very efficiently. In our app, we have a series of dominoes that appear on the stones target, and then you can trigger them using either an on-screen button press or a virtual button, and it has sound. And what that shows you is how to integrate sound, which is available mostly on the Java side, with the native parts of the SDK. We have a comprehensive AR platform with cutting-edge features. We have a great community of developers and fantastic technical support. And the best of all, it's free. So I'd like to invite every developer out there to come and try our SDK and build exciting new applications.
So hopefully that gave you a very quick overview to the different vision capabilities in the SDK, the natural feature detection, the marker detection, and then the virtual buttons, which are, I think, a very different form of interaction that you don't get in traditional apps. And then since the time this video was made, there are other things, other samples that we've added to the SDK. We've actually opened up access to the background texture, the video preview from the camera directly in a GPU texture, so you can just apply shaders and manipulate the background itself. And I'll show you some things later that show you how to do that. And there are many more sample apps that you can use. So it's a nice little package that you download, and it's all ready to go. And our forums are just a wealth of information out there that you can get answers to pretty much any question out there. So what does developing with Vuforia look like? Look, if you've done mobile development before, this is no different. You download our SDK, we provide a library there, and your app just links to it. And that library has all the computer vision technology out there that looks through the camera, processes the image, determines where your real-world objects are, and then tells you where it is in real time. And then along with this, you bundle some target resources, and these resources are what that tells the library what to look for when you're looking through that camera view. Are you looking for the stones image? Are you looking for your own image targets? Are you looking for a box? That's basically it. It's just a bunch of resource files. And then everything else, what you actually do once you've detected it, once the SDK detects a real-world object and tells you here's where the image is, that's all up to the app. The assets, whether that's 3D, 2D, the logic of where to put it, the rendering, whether you do OpenGL, whether you want to use your own rendering engine, whether you want to use Unity, all that is up to you. So the only question now is, how do you create these target resources? And for that, we have an online tool. You go to our developer portal, you submit a JPEG or a PNG image, and you can download a target dataset file that you can either then host on your own servers, or you can bundle it with the app. And you can swap it out at runtime. So each target dataset can hold about 80 images today, and then you can swap it out for another set of 80. So in terms of tool chains, if you're a sophisticated developer, then you would probably use Eclipse. If you're using Android, or if you on iOS, you would use Xcode. And what that means is you'd have to bring in your own rendering engine, or you would have to code to OpenGL directly. It gives you a level of control of the SDK, which is, although available in the Unity version of our toolchain, it's not that obvious. It's meant mostly for developers who like to play around with the APIs directly. And then, of course, if we have an extension that plugs directly into Unity, and that gives you not only the whole cross-platform ease of development, but it's also a much more intuitive and simpler way to build an app. And that's what I'm going to show you in a little bit. Of course, Unity costs something. The tool is not free, but our extension is free. There's no cost to download our extension and use it, but Unity has some cost to it. This is a view of our target management system. This is where you would go on our developer portal. You'd submit an image, so you'd just say, where it says create a trackable. I don't know if you can see this here, right here. So when you say create a trackable, it'll pop up a little dialog box, and you can just upload an image there, and then it'll pretty much create. It is sort of real time. It's a little bit of a blocking call, but it'll create it immediately. And then you can choose which ones you want in your data set. You just check the radio buttons and you can download them. What's nice about this tool is it has this rating system, and you'll see some of these targets are actually poorly rated. And this rating is just a very simple way of telling you how well it can be tracked. Something that's 0 obviously cannot be tracked, and something that's 3 or more is generally pretty good. And if you click, and I don't have a screenshot for this, but if you actually click on one of these images, it'll open up a separate view, which is sort of an image summary, where it gives you hints about how to improve the image if it needs improving. Right? So suppose you uploaded an image and it said, it's only a 1-star, and you actually clicked on it, it'll give you some simple hints saying, okay, you probably want to add more detail here, change the contrast here. It gives you some simple tips on how to improve it. Just earlier this week, we put up a target design guide up on our developer portal. So actually, even before you do any of this, if you take a look at that design guide, it tells you what makes the SDK rate some of these highly, and what makes it nicely trackable. So that design guide is very useful for visual designers when they're actually designing this game board or target. I'm not even going to try to do that here because our internet connection here is really bad. Okay, so we've had two major releases of the SDK as a platform. We've had the 1.0 SDK was there for a long time, and then in February we had the 1.5 version, which was more of an incremental thing where we allowed access to the texture, but there were a lot of performance improvements. And I don't know if you've watched the first video that I showed you, that was actually shot with the 1.0 SDK, so there was some of those blocks that were there while they were tracking pretty well, there was a little bit of jitter. So now when I show you this video, you'll see the difference between 1.0 and a 1.5 just in terms of performance. So especially the tracking improvements, when you're actually shaking that phone a lot, you might question when does that happen? It actually happens quite a bit, we've noticed, and when people are using phones, they're making these very short motions that are really fast. Even that little bit of a jerk causes the thing to disappear. So being robust to such motions is really important. That and tapping motions, because you have a lot of interactions where people are pressing or tapping the screen, and that causes like very fast motions for these phones that might actually cause distortion in the camera image, and you lose tracking. So just by being robust to such simple things makes our platform so much better and makes the user experience that much better. Okay, so just a quick note on platform traction. We've really grown a lot, and we continue to grow. We have more than 25,000 registered developers. This is just on an upward trajectory here. Just the sheer number of models of phones on Android. On Android, we support all 2.2 devices and above. So all 2.2 devices, that's a lot if you think about that. And there are more than 800 applications that have been built and deployed for free with no markers or watermarks or anything in our camera view. We don't charge for this stuff. Here are some samples of brands that have been using this, not once, but many of them on repeated campaigns. So it's clear that there's some value in AR in general, and they see value in the platform too. Okay, so with that, let's actually switch gears and talk, and let me show you quickly how our tools integrate with Unity. I'm going to build a very, very simple app. Let me actually show you what I'm going to build first, and then we'll go from there. So I have this this little camera rig here, and all it does is it's just meant to hold the camera here, and I have a webcam that captures what's on the phone here. But everything is being done on the phone, and this is just my USB thing for deploying the app later on. So so here's the app. We're going to recognize the stones target because that's the one I'm carrying around. And as soon as it recognizes it, there's a little teapot. And then we've put a virtual button there. So when I occlude it or cover it up, so you see some steam coming out, right? Some nice little particle effect. So it's a reasonable app. It's not that simple. It is pretty simple, but it's not that simple either. So there's some real assets. So that's it. So let me show you how to build that app very quickly. Okay. Let's shut this down for 2 minutes. Quit the app. Let's keep this aside. Okay, so the first thing we're going to do is start up Unity, and okay, so you'll notice when it started up, it already opened up a project, and this was just the last project I was working on. By default, it seems to open up the last project you're working on. And I like to show this because it gives me a quick way to introduce, give people who are not familiar with Unity a quick introduction to just the Unity environment. So this is what they call the Unity editor, and it's basically the WYSIWYG tool where you just drag and drop everything and build your scene. We'll start here. This is the project window. The project window is where you import all your assets. So this is where you pull in the Qualcomm Unity extension, your 3D assets, everything that you want to build the scene. This is where you would put it. There's a special construct here which is Unity specific called a prefab. A prefab is nothing but just an asset that's bundled with a bunch of behavior around it, scripts and animations and all kinds of things that you can just instantiate in your scene and create multiple instances of those. So Qualcomm, we have the Qualcomm AR extension. There's a bunch of prefabs that are very specific. Some of them you probably recognize based on the terminology I introduced earlier: images, multi-targets, virtual buttons, and frame markers. We have something special called AR camera, which I'll come to in a second. So this is the project view. The next view is the hierarchy, and in this window, this is where you build a relationship between the different assets in a particular scene. So you would drag things and put it here and build that entire hierarchy out. And whatever happens in the hierarchy is reflected here in your scene view, so you can actually see it visually as you build it. So it's very, very intuitive. And then one other nice touch here is what we call the inspector view. The inspector basically shows you all the characteristics associated with a particular prefab. So if I click on image target, for example, it shows me a whole bunch of things, what the position is, which it doesn't have any position in the scene because I haven't yet dragged and dropped it here. I haven't added it to the scene. And special, and some things out here which are very specific to Qualcomm, the Qualcomm AR extension. And then this is the scene, of course, is where you actually visualize what you're building. So with that, let me actually start from scratch. Let's build a brand new project. We'll go with the default name. Okay, so it's all blank. The only thing you have is the Unity main camera. Unity is a game engine, so it has a camera for the game itself. It's not actually relevant for AR, so we'll get rid of it in a second after we bring in all our assets. The first thing we're going to do is actually bring in the assets. Now, there are three types of assets here. There's the Qualcomm extension that you need for AR. There's your own assets, the stuff that you want to put, the augmentations and the particle effects. So in this case, it was the teapot and then the steam particle effect that you have to bring in. And then lastly, what you also need is the target resources. Remember in that diagram where I showed you, you link to the Qualcomm library, the Vuforia library, and there are target resources that you have to bring in. So let's bring those three in first. So you want to go to Assets, and then you go to Import Package and Custom Package. Now, I've already downloaded these three assets and kept them here, right? So there's the extension here, the demo.unity package is the actual target resources or the target data set. And then your application assets are the teapot and the steam assets that you need. So let's start with the Unity package. Okay, so you just import everything here. Okay, so now let's go get the other assets. So go back, same thing. Get the teapot. Import the teapot. I'm going to uncheck this script because I don't need it for this particular demo. It's related to a much longer tutorial, so I don't need to import that. Okay, and then the last thing is the target resources that I was telling you about, so which is demo. Okay, so now we've imported all the assets and we're ready to start building our scene. Okay, the first thing we're going to do is get rid of this main camera. We don't need it. This is the virtual camera that Unity has by default for the virtual games they build. But in AR, you need to tie it to the cell phone camera because that's the camera that looks into the real world. The real world is your scene essentially. So let's delete that and let's go into the Qualcomm AR extension and the prefabs, and we've actually created an AR camera that has all this behavior packaged for you, so you don't have to recreate that stuff. So let's drag the AR camera here. So we've created the AR camera. The next thing we need to do is we need an image target, right? Because we're going to recognize the stones target. So let's pull the image target prefab here into the scene. So you'll notice by default it's blank because we haven't assigned any texture. We haven't told it, for this particular scene, we haven't told it what it is that we're trying to recognize and track. So we'll go to the inspector, and in the inspector there's all kinds of things here. But the one thing that we are interested in is this one, image target behavior here. And in image target behavior, it tells you what data set you want to associate with this. Remember, we can have multiple data sets, and you have to pick from which data set you want the texture loaded. So in this case, I have only one data set, so I'm going to pick demo, and it automatically picked the first target that's in that data set. But I could have easily have chosen another one, right? And it's immediately reflected out here. So since I did not bring the chips target and I only brought the stones one for our demo today, I'm going to pick stones. Okay, so now we set up our image target. Now we have to associate some content that you want to augment on it. So if we go down here where it says tutorial, I have my Steam and teapot content, right? So let's bring the teapot in here. So it automatically puts it out there. So you see, notice how every time I drag and drop something into the hierarchy, it automatically builds it in this scene view. So that's really the power of Unity. You can actually visualize this thing step by step. One thing here that we have to do is, because you want the teapot to be associated with the image target, meaning when you recognize the target, that's when you want the image target, that's when you want the teapot to be displayed. You actually have to make this a child of the image target. So let's go ahead and do that. So now you've built a hierarchy. When you recognize the image target, you put the teapot. That's really the behavior I'm trying to define out here. Okay, so the next thing is we want to associate the steam, right? So the steam, again, let's drag it here, and we have to position the steam. You don't want the steam coming from anywhere. It has to come from the spout here. So let's drag. You can move this thing around here, right? And then if you look in the inspector view, we have this emit checkbox here. And if I click on that, you can actually see the particles coming out. And the nice thing here is that I can view it from different angles to make sure I've positioned it correctly. And I usually don't position it correctly, but in this case I got it bang on. So we're good with where it is. The only thing now is that, again, the steam behavior is associated with the teapot. So you have to make that now a child of the teapot. Okay, so we'll go ahead and just drag it on the teapot, and it automatically connects the two. Okay, and then the last part here is we need to define how the steam is triggered. And you know what I did? I defined a virtual button and I covered it with my hand, and then the steam came out. So let's just go ahead and do that. For that, we need the virtual button prefab here. And since the virtual button can only be defined on an image target, let's just go ahead and drag and drop it directly on the image target, so it's a child of the image target. So when you do that, by default it puts it in the center. So we now have to move it around and find a place for it. So I'll just take this, right? I don't know if that size is good enough, so I can go to the inspector here and change that size if I want to, right? So I can make it big, or it's probably too big. So I like those numbers because I've played around with those and I know what the right numbers are there. But you can play around. You can see how it automatically adjusts it as you touch the inspector there. There's one other thing here we do to complete the behavior of the virtual button, and that's the script. There's a virtual button event handler, and this script basically says, hey, when somebody occludes me, so if you look at this thing, on button pressed, which is a callback that the SDK calls, you have to do some action. And in this case, it's basically setting that little steam emitter flag to true so that you can actually see the particles coming out. So let's go ahead and drop the script on the image target. So that now the image target associates with it and sends that callback now repeatedly. Okay. So now let's actually choose the data set. We've chosen a data set, right? It was a demo set. Now, because you can have multiple data sets, what we allow the developer to do is actually load different data sets in memory in a background process, and then you can activate them depending on which one you want. So that way, at runtime, you're not wasting time trying to load this data set, because it's done in an asynchronous task in the background, and it might actually take a little bit of time. So you don't want that. In order to minimize delays from a user experience point of view, you tend to load one or two data sets in memory and then activate them rapidly. So let's go ahead and activate our data set. So if you go to AR camera, right, and you go down, in the data set load behavior, you actually have to tell it which one. So right now it's none. Let's pick demo. We only have one in this case. And then we say load data set demo, so it loads it on default. Now the only thing missing in our scene is some light. All scenes require light. So if you go to game object here and say create other, and I'll just pick a directional light. Okay, by default it placed it in the right direction, so I already have some light here. But if you go and click here, you can actually change the positions of the light, right? You can do whatever you want here, so it's nice. I think the position we have right now is good enough for this. So that's it. We've built our scene, we've added all the behavior we wanted, We activated the right data set, and we put some light in the scene. So now what let's just run it. So okay, let me start up my webcam so you guys can see what's going on. Okay, so I've got my webcam live, but I haven't started the build process. I'll go back here. I'll say File, Build and Run, and I'll pick Android. Right? And we'll give it some name. Oh, let's go here. Let's just call this test.apk. Okay. Just a few more seconds. Okay, so it pushed it, it started up the app. Okay, so you see the real world, and now let's point at our stones target, and there you go. There's the teapot, so that's one part of it. And now let's have a little bit of virtual button interaction, and you see the particle effect coming out. So that's it. It's actually really that simple. So obviously this app, I had all the assets with me ahead of time. What I really wanted to show you was how it was easy to bring all these things together once you've created once you've decided what the experience is and created those assets. I mean, pulling in our tools, the extension, the target resources, all that is really, really simple. So hopefully you guys will give it a try. I don't save this. Okay, so let's switch back here for a second. So we've gone over the platform, we've looked at the traction, and I showed you a very quick tutorial, and hopefully I convinced you to go and try this out for yourselves and showed you how easy it is to use our tools. Here's our website, developer.qualcomm.com/AR. You can go and download the SDK. We also have a conference later in June, which is a Qualcomm Developer Conference on the 27th of June in San Diego. There are lots of sessions on AR. Definitely come. There's a lot of announcements related to Vuforia, so you can see what's coming on our roadmap. I have a discount code here, ARE2012. I think it's about a 20% discount that you can get if you register now. So I invite all of you to come down and visit us in San Diego. So with that, I'll take any questions that you guys have. Yeah, please. That's interesting, yes.
I mean, it's kind of it's a real pain to carry the thing you have, you know, and even to carry the phone and point it out, and if you just had it on glasses, it would be so much better. It wouldn't it expand the market significantly?
I've tried glasses on. I think glasses are very interesting, and I think it definitely has a very, it definitely has some niche use cases where it makes a lot of sense, but I still think that for most mainstream consumers, the cell phone is where you will have the bulk of these AR experiences, just given a lot of the technology. There's a lot more technology research and user experience research that has to go into glasses to make it more mainstream. But yeah, it's definitely interesting, and it's good to see a lot of companies, not just Google, but a lot of companies, I think this morning also that I saw a couple of others talking about glasses and making progress out there. Yes?
I'll ask two questions.
Sure.
Any planned support to Windows, and is there any specification allowing developers to add assets?
Let me answer the first question. I'm not sure I understood the second one. Windows is definitely a very important platform for us. We're committed to bringing this to all partner operating systems, and Windows is a big partner. I just don't have a firm timeline for that today.
Okay, so the second question.
Yeah.
There is a way to include assets in an application.
Yeah.
Qualcomm is providing the assets.
So you're talking about the augmentations or the images?
An asset could be a teapot. It could
Okay.
be a steam effect. It could be a region on a tracking point.
Okay.
So is there a specification allowing third parties to design these assets and include them?
Okay. So I'll make the distinction. The assets that there are two types of assets in what you asked me. The first type is what I call augmentations. So anything you put on the target after we tell you we've detected a particular target. And so we say, here's the image, right? We'll give you in real time, we'll tell you, here's exactly where the image, here's where your camera is relative to the image. And with that information, you can actually put something in the real world. What you put there is up to you. There's no specification there. It depends on the rendering engine you would use and what it supports. If you're writing OpenGL directly, you have to see how to render with OpenGL. So we don't dictate that. The second part of your question was, how do you specify those what you want to recognize? And there is no specification for that. We make a tool available. You just upload a JPEG and you get a data set out of it. Yes, sir.
Can you talk a little bit about what the experience is like running Vuforia apps on a Qualcomm chipset versus other company chipsets? How different is it? How well is it accelerated?
Sure.
Pardon me for a moment. If you're going to ask a question, if you could come to the mic. If not, Roy, if you can...
I can repeat the question. Okay. So this particular question was, how well does Qualcomm run on, how well does Vuforia run on non-Qualcomm chipsets? What's the difference really? So we work on all, as you rightly pointed out, we work on all chipsets, not just on Qualcomm, but we are optimized for Snapdragon because we have unique knowledge of that hardware. No matter what the chipset is, we will be best in class. That's our promise. So you can compare us to others, and you can see the experience yourself. It is competitive. It is better than everyone else, and it's. But of course, on Snapdragon, we are better. That's just we have just because we know the hardware and we've optimized it for it. Yes.
You mentioned the different types of applications that you can make with your toolkit. I'm
Yes.
just kind of curious, so far from the applications you've seen in the Android or the App Store, which ones seem to be the most popular or the most successful?
The ones that are promoted the most. I think I've seen all applications, all kinds in all categories. The marketing and interactive media is where we're seeing the bulk of the traction. Partly because that's what they are for. People promote the brands promote them heavily. Anything that gets featured in Google Play, you'll see a lot of traction for that just because people try it out. But to answer your question more directly, it's basically marketing apps. That's where we're seeing the bulk of the traction and the popularity. Yes, sir.
Would you describe the skill set? Does it include non-programmers who use this as an authoring system and application generator for artists, for example?
Sure. Sure. So the question is, what's the skill set of the developer who wants to use our tool chains, build AR apps with Vuforia? We try to cater to a broad range of developers with all kinds of skill sets, but the reality is, if you're trying to use our Unity extension, you need to know Unity. I'm personally not a Unity expert, but I was able to show you how to build a Unity app very quickly, and I learned that from other people there. So I have to believe that it's not that hard. But if you are trying to build more advanced AR experiences, and if you're using Unity, then you need really good Unity skills. Or if you're not using Unity, then you have to know rendering and graphics and C and C++. You need to know the native environments like Android and iOS and how those platforms work. So it's a fairly sophisticated skill set. I mean, the nice thing about Unity is it takes care of a lot of that. Everything I did today, I mean, the only thing that was Android specific was that build and run at the last minute, and I had to pick Android. I might as well have picked iOS, and it would be okay. So it takes away those issues, and believe me, they can be quite challenging. Yes.
Can you talk some about the technical limitations, like the number of images you can recognize at a single time, the frame rate, things like that?
Sure. So the question was, can I talk about the technical limitations, specifically the number of images and the frame rate, number of images I can recognize at a time, and the frame rate. So I'll answer that. The number of images that you can recognize at a time. So simultaneously in the field of view of the camera, we recommend up to 5 images, and really it's a function of how much horsepower you have on that particular phone. Some of the higher end phones you can go even higher because they have a lot more RAM. And you have dual core CPUs and it works nicely, but on the lower end devices, it doesn't work as well. So we generally don't recommend more than 5 simultaneously in the field of view. But you can have up to 80 images in any one data set that's active. So you can search from a data set of 80 images active on the phone. And then if you don't find it in those 80, or if your use case demands that you look for more, you can use an application level trigger to swap that data set out for another set of 80. So in a way, it's a little clunky way, but you can actually go scale pretty high. Frame rate. I think we don't actually give out specific numbers on frame rates, but we try to do it as fast as possible, and the experience is very, very fluid on most devices.
Back to the question about optimization for your platform. Is there any particular hardware acceleration or anything specific in the Snapdragon platform that's augmented reality right now, or are you just using the standard graphics and using anything else?
Sure. So we use a layer called FastCV. I don't know if you guys are familiar with FastCV. It's another Qualcomm product, and it's basically a low-level computer vision library that takes a very holistic view of the SoC, right, of the entire silicon platform, and says, on this particular platform, where does it make sense to run a particular algorithm? So there's all kinds of algorithms in there. There's corner detection, color conversion, pyramid building, and all kinds of algorithms that FastCV has. And you can download this and build actual computer vision apps with FastCV. So I can't specifically say which core you use because it really depends on the chipset you're running. But there's universally today we have Neon acceleration in there, and on Snapdragon, because we have our implementation of Neon is actually called Venom, so it's slightly different from the standard ARM implementation, so that provides an additional boost out there. But I do know that FastCV has its own evolutionary path where it's looking at other things like GPU and DSP and all that. So.
And I just have a real quick question.
Sure.
I know that you guys have the video of the presentation that you gave on your site.
Yeah.
Do you have any examples up there, essentially for people that they can reverse engineer, kind of like the Teapot example or something like that?
All our sample apps, they're not on the site, but if you download the SDK, they're in there. Okay. So you can see how to swap out a Teapot for some other asset. And by the way, this question is one of the most common questions on the forums. So there's at least 4 or 5 threads which show you exactly how to do this for native, for iOS, on Unity, and it should be really simple.
Excellent.
Yeah. Yes.
Are there any plans to open up the online tools as an SDK, or at the very least as an API?
I think you're talking to the referring. So the question is, are there any online tools to open? Are there any API? Are there any plans to open up the APIs for the online tools? Correct.
Correct.
Okay.
Or at least have it available as a downloadable SDK.
Right. So I think we recognize the issue that when you're trying to create a number of targets, it is an issue that you have to upload each of these targets. And all I can say at this point is that we will have a really good solution for this that should mitigate this to a large extent. I just don't have a specific timeline, but you should definitely come for our Uplink conference.
Then just one more question. Yeah. If you can answer this, what are some technological barriers that you guys have right now that you'd like to see improved with your software in the next
Sure.
year?
Our vision for AR is that our vision for the phone is that the camera is like an eye, right? Today we can recognize some objects, some NFT objects. Tomorrow, what we want to recognize is all kinds of objects in the room, such that the camera, where you can point the phone at any object in the real world, and you can interact with it in a way that you've never been possible before. So we're working towards that. You know, you saw some of that on the Sesame Street demo that we've done, where you can see 3D object tracking. That's obviously needs to be improved quite a bit, but it's even pretty compelling even in its current form. So that's generally the direction we're going. We want to recognize any object anywhere, get to this whole vision of AR anytime, anywhere. There was someone here who had a question. Sorry, before that.
What are the online tools and what runs on the phone?
So what are the online tools allow you to create a data set, a resource file that tells you what you want to recognize. So you take that resource file, you put it in the app. On the device, what you have is a library, as a Qualcomm library, Vuforia library, that uses those resource files and then detects and tracks in runtime. Does that make sense? That's the distinction? Okay. Okay, so there are a couple of questions here and here. So we'll go from here, sorry.
Yeah, maybe it's a related question, but how much of the application runs on the device itself versus how much of it runs in the cloud or
Okay. All the Vuforia part runs on the device. There's no cloud-based recognition right now. The tracking is all local on the device. Okay.
Are you guys thinking at all about supporting depth cameras and depth sensing in the future?
Research right now. So I don't have any firm product commitments on that side.
What would your opinion on the value of that be? Would that be a huge value to you guys if you had access to great depth sensing technology?
I think so. I think it's definitely valuable. I just don't know in what form or in what commercial form that would take. Right. A couple of questions here.
Yes, I guess for an optimization point of view, as multiple targets begin to get tracked and they go in and out of the view frame,
Right.
Is any kind of spatial, I guess, data bank kept for that, or do they have to be reacquired? Those targets have to be reacquired every time they come to view?
Okay, let me make sure I understood the question. So the question is, if you have multiple targets and then you're moving the camera around and you're seeing one at a time, is that, or multiple?
Any from 1 to n are going in and out of your view frame, or does it have to reprocess that and reacquire those targets each time, or does it maintain sort of a small cache of location of what's around it?
It depends on how you use the targets. So there's a couple of ways to do it. If you use it as standard image targets, where like how I showed it to you in the app right now in the tutorial, where you just have multiple image targets, then you would it's essentially a reacquisition. So you lose tracking and then you come back. You'd have to be able to handle state in your app. However, you could define the spatial relationship of these images using something called a multi-target. And the multi-target is the box example, right? Where it's a simple example of doing simple 3D objects. And what we do in that in that example is we say, here are 6 faces, and here's the relationship between these 6 faces. You always have face 1 here, face 2 is at 90 degrees to it, and here's the texture for that. Instead of saying 90 degrees to it, you could make them all planar, right? And you can say this is the relative order in which they will appear. If you do that, then you get this one coordinate space for the entire thing, and you can go all around it, and the state is sort of maintained for you. So you get one pose for the one position and orientation of the camera, which we call pose, relative to that entire map, if you will. Yeah.
So can you speak about gestures in relation to the multi-target? Is gesture multi-target? What's your plan for gestures?
When you say gestures, you mean hand gestures?
Hand gestures, some gestures.
Yeah, we don't do gestures right now. Vuforia does not support detection of fingers or hands or anything like that.
It sounds like the multi-target is similar to a gesture.
No. So a multi-target, you still have to use natural feature images, so any image that you take of the real world. You can't like take a picture of your finger and then put those together and it won't track. Yeah. You still need a lot of features in the image to be able to track it. Yes, sir.
Follow-up question. So how did you do the domino thing when the finger came to
Right.
keep off
Okay, so the question is how, if we don't support gestures, how did we do the dominoes sample app where the finger comes in the camera's field of view and actually topples those dominoes? It's a good question. So we actually cheated a little bit there. We used the virtual buttons there. We've defined a virtual button. And remember, the virtual button doesn't have to be, you don't have to touch it to actually trigger the virtual button. You just have to cover it up. So we covered with our finger there. So this is the thing, right? The SDK offers a lot of features, and using it in creative ways is what makes a great application experience. You don't need finger tracking to be able to do that, right? You can do things like determine specific, like if you have a specific area where you're, and if you can say, every time I occlude that area with my finger, something magical happens, right? That's all you need. And we actually go a step further in the domino sample where you can draw you can draw any series of dominoes. So the virtual button keeps changing its spot. You can change that dynamically. So
Is it the same as pushing buttons? Or because you had the button demo too, but I don't know.
right, it's exactly the same.
So it's including the button in that.
Yeah, it's basically a developer-defined region, right? You define whatever region you want on the image target, and you say, if an occlusion happens on this image target, then give me a button event. And that's all it is. It's a very simple mechanism. Yeah.
Are you planning to also support more different sensors, like accelerometer or light sensors, things like that?
So our goal is to, like I said, just going back to what we want to do from a product vision perspective, is to be able to recognize all kinds of objects and be able to track everything. If sensors make sense in that context, then we'll add support for it. Like if we have to improve the tracking in certain contexts, and like gyro could help in that particular context, then we will add support. Right now, there are no sensors in the SDK. It's purely computer vision. Yeah.
Like QR codes do actually. Can Vuforia actually collect the data of the user who is scanning the image target?
So the question is, like QR codes, can you collect user data from the user who's actually scanning the target? So right? We don't do that. You can do that. It's up to the app. That logic, I would say, is just pushed to the app.
Any more questions?
Lots of good questions.
All right, well, thank you, Roy, for your
Well,
time.
thank you all.
And we have a break. We'll meet back in here at 11:30 for AR Technology State of the Art.
Hi.
And if any of those presenters are in the room, please find them.
Sorry.